Hi guys, we are going to look at a review of linear functions and how to sketch linear functions. Okay, now this set of exercises here were given to you last year during the orientation week with Ms. Kumar, so you should hopefully have already done them, and if not, please ensure that they are done. And you can draw on this video as a review of what you may have covered during that time. Okay, so we're going to be focusing on things, and your goal is to be able to determine the gradient and y-intercept, and then determine the equation of a linear function. Okay, from different information given to you. Let's do it. Alright, so just picking up from what we've been working on transposing equations, let's see how we can, given some kind of linear rule, linear function rule, we're going to transpose it and put it in a particular form. So the way these equations are written currently with the x and the y next to each other, we call that the intercept form. And we'll look at a way of sketching these a bit later on that might explain why they're called an intercept form. Our job is to transpose that into the gradient form. Now the gradient form is when the equation looks like this: y equals mx plus c. So when the equation is in that form, then it's called the gradient form. So let's try the first two by hand. Okay. So they're quite relatively simple. Here's the equation. First one is we want to get the y by itself. So in doing so, first I have to move this x term here. It's a positive x term, so the inverse operation is I have to subtract x away from it. Subtracting 2x, so I'll have minus y on the left and then 9, and I subtract the 2x. Okay? And then finally, this being a negative y, I have to divide by -1 on both sides. So dividing by -1 is the same as multiplying by the -1. It's not going to change the value. And when I expand that -1 throughout, it's simply just going to swap the signs. So this will be now positive 2x, and that is a -9, and I'll write it in that order because now it's of the form y equals mx and the c. So there's my gradient form. Okay, so we've got m value being 2 and the c value equals -9, and I'm hoping you're already starting to think what names we give the m value and the c value. Okay. Let's transpose B and get it into gradient form. 3x plus 4y is 10. So let's get the y by itself. Looking at the x term, it has no sign in front, which means it must be positive. And so the inverse operation is let's subtract 3x on both sides. 4y is equal to 10, subtract 3x. And now, to get y by itself, the operation we have to do is divide by 4 on both sides. So 10 minus 3x, and in dividing by 4, remember that's the same as just multiplying by 1/4, a quarter. Now in expanding that brackets, this quarter has to multiply to both terms. I'll have 10/4 minus 3/4x. Do you think that could be written in a more simple way? Especially this fraction here, the first one, 10/4, really can be simplified, and we will get 5/2. Y equals 5/2 minus 3/4x. Okay, so our c value in this case, is it the 3/4, negative 3/4, because it's over here? No, you remember m number is always the number in front of the x. So m equals minus 3 over 4, and the c value is by itself as a term. So c is 5 over 2. Okay? Good. Trying to do that by cas, we need to, in fact, bringing up the cas here, we are going to now use the solve command to transpose. So, for instance, as an example, here's my solve command. Now, if I have a rule that, let's say, is y 9 times y and subtract 3 times x, and that is equal to 8. There's my equation. Now that's in intercept form. I want to transpose that into gradient form and solve for y. So in doing so, I must now have that comma, and I'm going to transpose for y, okay, to get y by itself as the subject. And enter. And voila, it gives me a gradient form. And remember, we need to interpret the cas answer and write it in an appropriate form. So in terms of y equals mx plus c, that now would be y, let's divide the 9 into both parts. So I'll have 3 over 9x plus 8 over 9. Okay? Can that be simplified a little bit more? Absolutely. Y is 3 into 9 goes a third. So a third x plus 8 ninths. And you can see you've got an m number of a third and a c number of 8 over 9. Okay? So knowing how to solve both using the cas and by hand is very important. So the general structure is use the solve command, then we enter the equation, okay, as we see it, comma, and we solve for y. Okay? Good. Alright, so we're going to now make a connection. What do we call the m number? It is the gradient. It's the gradient of the line. Now the gradient it measures steepness, or the slope, how steep it is. A large number gradient gives you a very steep slope, while the small number gradient is more flat. Okay, large number, smaller number. And negative, it's the other direction. Okay, so m is also determined by the rise divided by the run. Okay, and when we're trying to work out the rise, then the rise is determined by the difference in y values. So for instance, if we look at 2 points on a graph, this one and this one here, where one coordinate is 0, 5, the other coordinate is -1, 0. So what's the difference in my y values? Well, in this case, let's say the top one is our y2. Okay, so it starts at 5, and down here the y value is 0. Okay, there's our y1. And then we can see straight away we've got a difference of 5 there. What about thinking that the run now is just the movement going across, which is the difference in our x values, x2 minus x1. So from this point here, this point on the graph, my x1 point is a -1, whereas this point up here corresponds to my x value of 0, which is my x2. Okay, so 0, and for x2, subtract -1 for x1, and there I've got a difference of 1. 0 subtracted -1, we're adding, so it's just a +1. And there's your radius, gradient of just 5 units, +5 units, so it's travelling upwards. Okay, gradient. We can work it out as rise over run, or the difference in y divided by the difference in x values. Okay, next, how about our x-intercepts and our y-intercept? This one. The y-intercept is in fact the same as the c number. Okay, so the c number in the gradient form, well, we can see that y is equal to c when x is 0, simply because y equals mx plus c. When x is 0, we put a 0 in that spot, m times 0 plus c, and you get simply y is equal to c. Okay? Now, this is the point, and we can see on the graph here, this is the point at there where x is equal to 0, and we get a c value of 5, a y-intercept of 5. And altogether we can produce the equation of a straight line in gradient form, y equals mx plus c. So in this example, we worked out that the m number, the gradient, rise over run, difference in y divided difference in x is 5 units, so there's my m number, 5x plus the c number. Now c number we've worked out to be the y-intercept, 5. Okay, very good. So we're going to explore more techniques in which we can determine this equation of a line by drawing on gradient and y-intercept. Now, let's look at it from a slightly different idea. We have our rule for gradient, change in y, divide change in x. But let's see if we can work out what the gradient is by examining a graph. Okay? And one way of doing it is just visually seeing the rise and the run. Let's do an example E. So the gradient is rise over run. Now the rise, standing, let's say from some point along here, it goes up to a point up there. Okay? Now I would have to run across so many units, 3 units, and I have to rise up 3 units. So my rise is 3 and my run is 3, and the division gives me a gradient of 1. Okay? Quite straightforward. Why don't you pause the video and do the same for questions D and F? Okay. Let's now try if we have coordinates given to us, points. Looking from the graph now, let's work out example G. We've got the same thing, this time 2 points on our graph with coordinates, and we'll have a rise, a run going across ways, and then a run up to this point. Now, we don't have a scale to measure the rise and the run, but this time we have to do it by looking at the difference in y and the difference in x. So the gradient is given by the difference in y divided by the difference in x. Now my difference in the y values is looking at the most largest y value and the most smallest y value. What's the difference between 10 and 0? Well, it has to be 10. So 10 minus 0, and that gives me a 10. Now what about the difference in my x values? My x values are the first one's there. So it starts at -2 and it goes across all the way across up to 6. So going from -2 to 6, x2 is 6, subtract x1 is negative 2, and doing that subtraction, seeing the difference between those two numbers, we see there are 8. It is 8. So simplifying that, and we get a gradient of 5 quarters, or 5 over 4, as a gradient value. And then lastly, if we have no sketch to read from and to interpret, how do we get the gradient just from two given points in space, two given points on the Cartesian plane? So this is the most important. From 2 points only. Okay, let's look at example number A. Now, given we have points, I'm going to use the form that draws on those points, x1, y1, and x2, y2. So, set up your rule. Alright, now come back to our points in the question. We need to identify which numbers is x1, y1 and which numbers are x2, y2. So, I'm going to start with the first coordinate. I'm going to define that x1, y1. Okay? And then the second coordinate, I'm going to define x2, y2. And it's very important that I just write down above or below those numbers what they are, because I don't want to confuse them and put them in the wrong spot in my little rule or formula. So once I've identified which numbers are which, let's substitute them in. y2 is 4, y1 is 3, and that x2 is 2, and x1 is a 6. Okay, now let's simplify. I've got 4 take 3 is 1 over 2 take 6. Well, that gives you negative 4. And that altogether gives us a negative quarter as a gradient value. Okay? So what I'd like you to do now is, thinking about these examples, pause the video and try the other ones, the other examples that I have here to practice. Okay, let's put those together and see how we can sketch a graph. We're going to I'm going to sketch just one, and I'll get you to sketch the other two. Let's look at example number A. Now, how can we sketch the graph easily when it's written in this form? This is called the intercept form. Okay, and what's useful about the intercept form is that we can sketch it quite quickly by using a particular sketching method. Okay, we're going to sketch by finding the x and y intercept, and that's why it's called the intercept form, because it's the use of the method to sketch gives it its name. The x-intercept and the y-intercept. They are the points where the graph crosses the axes. The x-intercept occurs when y is equal to 0. That's anywhere along the horizontal axes. So I'm going to substitute y equals 0 into my rule. 2x minus 3 times 0 is equal to 12. And that means 2x is equal to 12, and divide by 2, I get x is equal to 6. So my coordinate I get from that working out is when x is 6, y is 0. Let's plot that point. 1, 2, 3, 4, 5, 6. There it is. And I'm going to label it 6, 0. Okay? Now let's work out our y-intercept. That's when x is equal to 0. Okay, that is anywhere along the vertical axis line. So let's substitute that into our equation. 2 times 0 minus 3y is equal to 12. So that means negative 3y is equal to 12. And divide by negative 3, and I get 12 divided negative 3 is negative 4. So from that working out, my coordinate is going to be, when x is 0, y is negative 4. That's a point on the Cartesian plane. Let's plot it. When x is 0, y is negative 4. 1, 2, 3, 4. We're going down here. Now let's label it. Like so. Alright, I've got 2 points in space. Now I can connect them with a straight line to sketch my linear function. So just carefully. Oop, terrible. Something like that. Okay? Now, what's most important that I'd like each of you to practice when we're sketching graphs is label the coordinates. That's one thing. Nice straight line with a ruler. That's the second thing. And the third thing is that at this stage, we're told that we have a function that we can use any real x and y value to sketch it. And it's continuous. It goes on forever. If I just extend my axes to 11, 12, 13, 14, then my graph extends. So I have to show that using arrows. Most important. So don't lose your arrows on your sketches. Now I'd like you to pause the video and practice sketching B and C in your exercise book. Okay, so these questions that I have here are available that I'd like you to practice yourselves. Okay, I'll give you some hints on what to do with them. Find the equation of the line that is parallel to the y-axis and passes through a coordinate 4, 7. So to do that problem, the first thing we have to do is know where that coordinate is. Where is coordinate 4, 7? So let me plot that on a Cartesian plane. 1, 2, 3, 4, and then going up. Oh, I'm going to run out of room. So let's say that's 2, 4, 6, 8. So 1, 2, 3, 4, 7 is going to be about there. Okay? Approximately. So there's the first point. Now, the question asks us to find the equation of the line that is parallel to the y-axis. What does it mean to be parallel to a y-axis? Well, that means it's going to run side by side without touching. So here's your y-axis. Okay? Now, a line that's parallel to that passes through this point has to be this one. Right through. And drawn carefully, running parallel, looks like that. And what is the equation of that line? Does it have a gradient? Does it have steepness? Yes. This one is not on an angle, it's straight up. Okay? So it has what's called like an infinite amount of gradient. And that is not something we're going to put in the equation y equals mx plus c. What we do have though is at any point along this line, the x-coordinate is always 4. But my y-coordinate changes. Doesn't matter what that y number is. It's going to be up, it's going to be down, big or small y number, but it's always just x is equal to 4. So the equation that draws this line is x is equal to 4. Okay? Thinking about that, try now and do part B yourself. Okay, These are a set of exercises for you to practice, looking at the ideas we've covered in the video. Please pause the video and record these in your exercise books and practice them. Okay, now finally we're going to put our understanding of the gradient and the y-intercept, we're going to put it together and come up with a very useful and important rule or formula that we're going to use. And this formula is going to be a rule to determine the equation of a straight line. Okay? So in general, the equation of a straight line can be determined by two independent pieces of information. One piece of information might be a point. The second piece of information might be a second point, or it could be something about the gradient of the graph. But you need two pieces of information to get your equation of a straight line. So let's look when 2 points are needed. From the 2 points, there and there, we can get a gradient of a straight line. Okay? Once we've got that gradient, then what we're going to do now is use that gradient value and put it in a formula. So let me show you how we're going to come up with this formula for a straight line. Equation of a straight line. Now the first thing I'm going to do is take our m equals y2 minus y1 over x2 minus x1, and I'm just going to transpose that rule. I'm going to multiply both sides by the denominator, x squared minus x2 minus x1, and it becomes this on the left. Then multiplying both sides by x2 minus x1. Then I'm going to rearrange it a little bit to get y all by itself, y2. Let's say we take some point P, doesn't matter what that point is, x and y coordinate, put that in, and my y now is the dependent variable y in my gradient form. So this rule here becomes a useful formula to work out the equation of a straight line. So let's try using this with an example and you'll see how good it is. Determine the equation of a straight line passing through these 2 points. Okay, now what I need to do is work out the gradient first. This is step 1. Step number 1. So my gradient is going to be y, using our rule, y2 minus y1 over x2 minus x1. I need to know, looking at my points, which one's going to be x1 and y1, which one's going to be x2 and y2. So I'll make the first coordinate x1, y1 and the second coordinate x2, y2. And let's substitute that into our rule. Make sure you do this step because I've seen many times some of these numbers gets put into this rule in the wrong spot and mistakes can be easily made. So y2 is 7, subtract y1 3 over x2 is 3, subtract negative 1. That gives you 4 over 4, which is equal to 1. Okay, so obtain your gradient. The next step, step 2, is to use our formula. This one. So, y equals m x take x1. So write it down first. Plus y1. Now, our x1 and y1 is simply this first point. Okay? And our m value is the value for m we worked out from the first part. So m equals 1 times x minus x1. x1 from the point is negative 1. Okay, and then plus y1. y1 from the point is 3. And then up here, so then y becomes x plus 1. Okay, and then I expand 1 into the brackets and it's still just that. And then plus 3. And finally, simply I get y is equal to x plus 4 by adding the 1 and the 3 together. And there's the gradient form, y equals mx plus c, and the equation of the straight line. Does that make sense? Okay, your turn. I'd like you to pause the video and see if you can do the same, use that same formula for these examples here. Now, finally, one more go at thinking about this intercept form of a straight line and how easy it is to sketch. When it's in this form, ax plus b is equal to c, or it could look like ax plus by minus c is equal to 0. Sometimes it's given to you when it looks like that. We're able to find the x and y intercepts really quickly. So when x is equal to 0, we're working out our y-intercept. Okay, so we substitute the 0 into the rule, and we get negative 2y is equal to 6, so that y has to equal to negative 3. Okay, and from that our coordinate is 0, negative 3. And we can plot that straight away. When x is 0, y is negative 3. 1, 2, 3. And label it. Yeah? And then let's get our x-intercept. So that occurs when y is equal to 0. So 4x minus 2 times 0 is equal to 6. That is when 4x is equal to 6, and so x is equal to 3 over 2, and we simplify the fraction. So our coordinate is 3 over 2, 0, or 1.5. 1.5 and 0. 3 over 2, 0. Okay? And now we can connect the dots and draw our straight line. Okay? Very good. See? What I'd like you to do now is review this work by studying the video, and please have a look at the exercises that were set and required for your homework. Yep, and we're done. What next class we're going to be looking at is start to look at the geometry of a linear function. And that's going to be fun and interesting extension to our learning. All right.